So today, Unit 6, Notes number 6, and this is getting us to the end of this first packet. So if you have not picked up the new packet yet, the yellow packet, please let me, actually this one's still white. If you have not picked up that new packet, let's make arrangements to come in and do so. Learning targets. Well, today we're going to be able to find the GCF of a polynomial, and you're going to be able to use the GCF to rewrite an equivalent polynomial in factored form. So a lot of what we did the last week, we're going to undo it. So we've been multiplying, and now we factor, which undoes that multiplying. And you're like, why am I going forwards and backwards? It's a process that we will eventually apply to the real world. So stay with us. The first one, we're going to go through everything. I'm going to really break it down, go through the longer way of doing this, and then show you some shortcuts once we really understand what we're doing. But first, let's talk about multiplying, all right? Because factoring is going to undo this process. Hopefully all of us are pretty good with seeing how we would distribute, and I already took care of this, so I'm not sure why I got to do this all over again. All right, here we go, pen. All right, so we're going to go ahead and distribute. Thank you for writing, Mr. Clear Touch Board. And I'm going to rewrite this the long way so that you see 2x times x, and then you see the 2x again, because we distributed it to both terms, times the 3. So you see a 2x here and a 2x there, because I passed it out. Now, Andrew, got a question? Out the 2x, we can see it in both terms. Remember, this is a binomial, right? This whole thing is 1 and then another 1, so 2 makes a binomial like your bicycle with 2 wheels. So we go ahead and we multiply. We add exponents when we have the same variable. So 2x squared, and then we multiply the 2 times the 3 and make 6x. Now clearly, this binomial and this binomial aren't the same. They look different, but they have the same value. And if you look closely, you can kind of see how the 2x is kind of in there and the x, yes. So we have distributed it in. Now it's our job to take it out, all right? So this is going to happen by thinking about what we put in or thinking about what they have in common. So a greatest common factor, GCF, greatest common factor. And if we look at the parts to this, if we look at the 2 and we look at the x squared and we look at the 6 and just the x and we break it up into two things, well, let's kind of write this in expanded form, right? We could write this as 2 times x, and we could write this as 2 times 3 times x. So I've broken it up into the smallest possible components that it could be. Now, what we want to then do is find what they have in common. The C there is for common. So they have a x in common, a 2 in common, and they have an x in common. So because they have those in common, we can say that the GCF is simply 2x. And no surprise, that's what we put into the binomial. Now it's our job to go ahead and take it out of what we put in. So we're going to take the 2x squared plus the 6x, and I divide out 2x. I take out the GCF by undoing multiplication, right? Division. So that will then give us 2 divided by 2, so there's just 1, which we don't really have to the right. X to the second power over x to the first is just x. So we're down to 1x, and then 6 divided by 2 is 3, and when we do 1 minus 1, because we subtract when we're dividing, everything we've talked about already, we get x plus 3. So there you have it. The same x plus 3 that we had before we multiplied it in. I got a lot of arrows and I got a lot of work up here, but basically what we've done is we've undone the multiplication process. We have factored, all right? And we're going to rewrite this as an equivalent expression to the original 2x squared plus 6x, all right? So that was a little different because we had something to go by, all right? We already had done the multiplication side of this. That's not always going to happen. We're not always going to see what happened before this, all right? So let's get into it with a few examples. And again, these are already the answers. Like you can think of it as the answers to the multiplication, and we want to get back to that distribution property. So I simplify this process for students. I make it so easy to do. All I want you to do is put an equal sign, a line, label it GCF, and then a set of parentheses. We're not going to do that same thing I just showed you. Hopefully that kind of broke it down and gave you a better view of what's going on behind the scenes every time. But basically what you want to think of is what's the greatest common factor? What's the largest thing that goes into 5 and 10? Now start with the smaller number because nothing bigger than 5 can go into 5. 5 is a pretty easy one because it's a prime number. It's either 1 or 5. Now does that 5 go into 10? Yes, it does. So 5 is a part of the GCF. Now when this first term has an x squared and this doesn't have any variable at all, they can't have that in common. So again, you think of a binomial as two things and it's got to be in both things. So the GCF for this is just 5. So then I go back and I undo multiplication with division. I divide both sides by 5. That's going to give me, well, just 1x squared. That's going to stay. And 10 divided by 5, a negative 2. You take this answer right here that you got after you divided it and put it in parentheses as x squared minus 2. You're done. Okay? Nothing left. It's as easy as that. Now there's obviously a little bit more behind it with the other examples we've done, but if you keep it simple, I don't think you're going to have much trouble with this. Next up, equal sign, a line, label it GCF, set of parentheses. Set yourself up for success. Know what you're trying to get to. Go ahead and think about a number that can go into 3 and 2. You know, right? Nothing can go into 2 and 3. These are both prime numbers. So they don't have a number in common, but this one has an x squared, which means 2 x's, and this has 1x. So that the most they have in common is that 1x. It's not the most they have in common. So now I take that GCF and I divide both terms by the GCF, by x. So if you want to think of it as being a 1 out here, sure. 3 divided by 1 is 3. X to the second power over x to the first. Subtract your exponents, you'd have 1x left. 2 divided by 1 is 2, and x over x will cancel out, and so you're left with just the minus 2. So go ahead, take what you got, put it into the parentheses as 3x minus 2. And just think for a moment. If you were to distribute, now I don't actually want you to, but if you were to distribute this x in, would you get this back out? You would, right? You're creating an equivalent expression, something that it's equal to. We'll do one more. So example number 3, 3x minus 21x squared. I don't have enough room to write it next to it, so I'm going to come down here, equal sign, line, GCF parentheses. That's what we're trying to get to, distribution. All right. So now we think about what can go into these numbers. Well, 3 and 21. Start with the lowest one, 3. Can 3 go into 21? Of course it can. So 3 is a part of our GCF. If this has an x and this has 2 x's, clearly they have at least 1 in common. So we're going to divide by 3x. Whatever we get when we divide, we put that in parentheses. So 3 divided by 3, 1. X divided by x, also 1. This doesn't make 0. You got to have something there, so it is just 1. 21 divided by 3, 7. X to the second over x to the first. If there's 2 in the top and 1 in the bottom, well, then there's 1 left over. Put that in parentheses, and you've done it. You've created an equivalent expression. Oh boy, what's all that? So in this next one, we've got a trinomial, which means there are 3 terms. And if there are 3 terms, that greatest common factor, that GCF has to be in all 3. So let's see if we can come up with the GCF. Well, I got a 2, a 4, and a 12. Start with the smallest number, 2. Nothing bigger than 2 can go into 2. So can 2 go into 4? Yes. Can 2 go into 12? Of course it can. 2 can go into any even number. So now that I've got the 2, what about a variable? I've got 2 x's here in the front, 1 x in the middle, but then no x in the third term. So if there's no x in all 3, it can't be a part of the GCF. It's not something that they all have in common. So I only divide by 2, no variable. I got parentheses here because whatever I get after I divide will go in those parentheses. 2 divided by 2 makes a 1. How about just x squared? 4x divided by 2, how about just 2x? And 12 divided by 2, good old -6. This is not the answer. We need to write something that's equal to what we started with, so we have to put it next to the 2, so it's x squared plus 2x minus 6. All right, and there you have it. Had to be in all 3 terms. Last and final one. I don't see any questions. Again, please, if you have questions, stop me. Use your microphone. Don't let me keep going here if something doesn't make sense. We need to rewrite this with a greatest common factor out in front inside of parentheses. Now, what is that GCF? It's got 3 terms. It's a trinomial. Like your triceratops with 3 horns, like your tricycle with 3 wheels, it's got to have it in all 3 pieces. Start with the smallest number, 3. Can 3 go into 21? 7 times. And 3 into 36? 12 times. All right. So 3 is a part of our GCF. And then we have x to the third, x to the second, and at least 1x. So guess what? They all have at least 1x. So we put down that as part of our GCF. So 3x is what we're going to take out. So let's divide by 3x and just use simple division rules for 3 divided by 3 as 1. And remember to subtract exponents when we are dividing the bases. So 3 in the top with 1 in the bottom leaves us with 2. And 21 divided by 3 would be 7. 2 in the top and 1 in the bottom would just be 1x. 36 divided by 3, how about just 12? X over x, you're out of here. You would cancel out. Now, this is not an equivalent expression until we put it in parentheses next to the term that we took out of all 3 pieces. And voila, a equivalent